Hello, good morning, and welcome to all of you. This is Rajesh Kumar Singhal, and I'm here to present a new topic on the energy balance. So, friend, this is a very interesting and important topic for the all the competitive pre and main exams. And in this lecture, we will discuss the different facts about the energy balance. That what is the source of energy in this atmosphere and what types of energy are absorbed by the plant and what types of energy are emitted by the plant and how the plant balance this energy to maximize their functions. So let's start our discussion for the energy balance. So friends, you know that sun is the important or sole source of energy in this earth planet or the and important for the plant growth and development. So this is the energy which required for the many important or crucial plant processes. So how we can define this energy balance? So this is a very simple definition that a balance between the energy input and energy output called as a energy balance. So this is a very simple definition, that is the balance between the energy inputs and energy outputs is called as energy balance. And you know that this is the spectrum of sunlight. So in the sunlight spectrum, it is made up of several rays, electromagnetic waves, that is gamma rays, X rays, ultraviolet rays. This is visual rays, then infrared rays, then radio waves. So there are many types of radiation are present. So you know that there is a one formula in physics, that is E barabar sc upon lambda. So E means energy is inversely proportional to the lambda is a wavelength. Okay. So there is a increase in the wavelength, means radio waves have highest wavelength, means it has lowest energy, and opposite of this, gamma rays have highest energy and lowest wavelength. Okay. And in the environment, only these three types of radiation: one is ultraviolet radiation, second is the visual rays, and third is the infrared. So these three radiations, ultraviolet light and infrared radiation, are due to the atmosphere, and most of these ultraviolet rays are absorbed by the ozone layer. So in the environment, mainly this visual rays, visual and infrared rays are present. Okay. And mostly effectively absorb the short wave solar radiations, means the radiations which is mainly 400 to 700 nanometer are important for the plant growth. That is also known as photosynthetic active radiation, PAR. So this is also important for the objective questions, that 400 to 700 nanometer rays are known as photosynthetically active radiations. So this rays mainly absorbed by the plant, and a relatively small fraction of incident solar radiations is reflected, transmitted and utilized for the many process. So friends, you know that there is a leaf surface. Okay. So when a radiations radiation strike, or this is a short wave radiation which strike on the leaf surface, then there will be a, it could be absorbed by the leaf, or it can be transmitted transmitted and it could be the reflected back. Okay, so when they strike, they lost the energy, and when they lost the energy, there will be an increase in the wavelength or converted into the infrared or long wave radiations. Okay, and this short wave is utilized for the many processes. This absorbed light is utilized for the important processes. And in bright sunlight, the net absorption of solar radiation is the main energy input to the leaves. So this absorbed light is the main input of for a plant. Okay, if such a leaf had no means to dissipate this energy, then its temperature would reach 100 degrees centigrade in less than 1 minute. So friends, you know that plants are sessile in nature. They cannot move from one place to another place, and there will be a very high energy in the form of short wave radiation in the atmosphere and long wave radiation in the form of heat. So if there will be a no mechanism to dissipate this energy, then there will be a possibility then that temperature increase by the 100 degree centigrade within a 1 minute, and it can kill the plant. Okay, so a leaf emits the long wave infrared radiations in the form of heat. So they dissipate this energy in the form of heat. At the same times, it absorbs the long wave radiations emitted by the surrounding objects or by the sky. So long wave radiation mainly emitted when the short wave are strike on the leaf surface, that they will reflected in the form of long wave, and also some long wave are absorbed which are emitted by different surrounding objects is like water vapor or by the sky. Okay, so the net emission emission and absorption may be, so long wave radiation emission and absorption may be negative or positive, because if plants are absorbing more LR, then there will be a positive or adding of the long wave radiation. If they are emitting, then there will be a negative. So this is about the energy balance. So two component of energy balance we have discussed. First one is the short wave, second one is the long wave. Now third is the convective heat transfer. So when there will be a temperature difference between the leaf and the atmosphere, temperature gradient, this is temperature leaf and air, then there will be a convective heat transfer. So this is a third component which reduces the heat load. Okay, and this convective heat transfer take place in the direction of temperature gradients, means the heat move from the high temperature to the low temperature. Okay. So this is the third component. Now fourth component is the transpirations. So the another major component of the energy balance which is useful for the cooling of the leaf, and that is transpiration. That is lambda E. Lambda is the energy required for the evaporation process, and E is the transpiration. Okay. So this is the fourth component, and the last component is the metabolic energy. Metabolic energy. So metabolic processes generate some heat, although this is very typically very small. So this is very small component compared to the other component of energy balance. So this is the five components. So some heat are released during this metabolic processes known as metabolic energy. So these are the five components of the energy in the plant. And when the temperature rises in response to the sunlight or during the daytime when the temperature is very high, most component of the energy balance that contribute to the cooling increase in magnitudes. So when the temperature is high during the daytime, so the component which are responsible for the cooling of the plant, they increase their magnitude. When? कब तक? Until their energy gain and loss are in a balance. So when the energy gain and loss are in balance, there will be no heat transfer. And at this point, the leaf has reached in an equilibrium temperature and the sum of all the components of are equal to the zero, that is known as energy balance. So SR net, LR net, long wave radiation net, convective heat transfer, evaporative and metabolic energy, that all components equivalent will be zero. So this is energy balance. So already discussed that short wave radiation. These are the five components. First one is the short wave solar radiation, that is mainly 400 to 700 nanometer, also known as photosynthetic active radiations, and the incidence radiations, which is solar radiation in reflectance and transmittance, means solar radiation. This is in means absorption, then reflectance, and then transmission. So these three possibilities is there. Then long wave radiation, that is mainly reflected or that is transmitted. Okay. And convective heat transfer, that occur between due to the temperature gradient. Okay. Then evaporative energy exchange, that is useful for the transpiration process. And last one is the metabolic heat generation, that is produced during some biochemical processes, that is very small but very high in case of inflorescence. So these are the component of the energy balance. So friend, now discuss the details about these components. So first component is the short wave radiations. So this is very important input of the solar energy, that is absorbed by the plant or absorbed by the water molecules present in the leaf and also reflected, that is reflected and transmitted in the form of infrared or reduce the heat load of the plant. So under the condition of high radiation load, so we can say during the daytime, also when there will be a shortage of water, so there will be a water stress. Many shrubs changes their leaf angles, means they stepping their leaf angles related to the sun, so they avoid the or reduce the solar short wave absorptions. So this is a mechanism, that stepping of the leaf angle to reduce the absorption of short wave radiation and reduce the high radiation load. Okay. So they reduce the midday solar radiation input. Okay. When the temperature are warmest. But opposite to this, they increase the absorption of solar radiation or input of energy in the morning and evening hours when the irradiation is less and temperature are cooled. Okay, so during morning and evening hours they increase the solar radiation absorption. Okay, so that time their angle become progressively more horizontal. In wetter communities means there will be a ample or more water present in the soil, then they changes their leaf angle, which increase the solar radiation absorption during midday also. Okay, so there will be a active leaf movement that is known as heliotropism or sun trackings. Means leaf are means following the sun. Okay, they also may also orient the leaf perpendicular to the incidence radiation, that is known as heliotropism, that maximize the absorption of solar radiation under the condition of low temperature and adequate soil moisture. Means when the temperature is less and adequate soil moisture are present, the leaf movement is diheliotropism, so they maximize the solar radiation absorption. And when exposed to the high temperature and water stress, leaf may become paraheliotropic. Okay, so the leaf orientation is parallel to the insert. Means if leaf are coming to this, the leaf is perpendicular to the parallel to the incidence radiation, so to maximize the minimize the solar radiation for the lower leaves. Okay, also the wilting and leaf rolling are additional mechanism by which leaves reduce the incidence radiation under water stress. So some leaves are reduce the leaf area by the leaf rolling. So less leaf area are available for the absorption and the wilting of the leaves, so they reduce the leaf area, so they also reduce the absorption of solar radiations. In some plants, surface reflections means they change their surface property, means there will be an accumulation of some reflecting wax layer, so they reflect wax layer or short white layer or salt crystals, so they reflect more, the reflection is the more. Okay, so they reduce the absorption of solar radiations, and a small parts of this solar radiation absorption is emitted as a fluorescence, mainly during the process of photosynthesis. Means they during the photosynthesis there will be loss in form of heat. Okay, so this is about the short waves. Then come to the long wave radiations. So friends, you know that all objects above the 0 degree Kelvin emits the energy, and heat loss through the long wave radiations is a major component of leaf energy. Okay, so the negative radiations balance of a leaf under a clear sky at night causes its temperature to drop below the air temperature. So when the sky is clear and during the night time, when the temperature is atmospheric temperature is less, so that time the leaf temperature is decreased more than this atmospheric temperature, which may cause the condensation of water on the leaf. Okay, so for this the long wave radiation are responsible, means more long wave are radiated, means plant radiated more heat. Okay, and next component is the evaporative energy exchange, which is negative during the daytimes. Means During daytimes, plant release this energy as a to cool the plant, but during the night time they absorb because they reduce their temperature are less than the atmosphere. Okay, when stomatal conductance and evaporation heat loss decline in the leaf temperature, increase in both evaporation heat loss or increase in the water vapor concentration inside the leaf and convective heat exchange. So when the air temp there is a air temperature and canopy temperature. If there will be a decrease in the canopy temperature, then the air temperature. Okay, so this occurs in the during night time. And metabolic heat generation is small, already discussed. Okay, and last component is the convective heat transfer. So the magnitude of this convective heat transfer depend upon the boundary layers conductance. Boundary layer conductance means this is the leaf, and at the leaf surface this is a boundary layer. Okay, so the boundary layer is the layer of air, layer of air that is close to a leaf, means the atmospheric air near to the leaf surface is known as boundary layer, whose gas concentration, CO2, H2O, temperature and pattern of air flow are modified by the leaf. So this boundary layer pattern are regulated by the leaf characteristics. Okay. So the heat transport across the boundary layer is related to the boundary layer thickness or thinness. So the heat transfer from the leaf to the atmosphere is depend upon the thickness of this boundary layer. Okay, which also depend upon the atmospheric conditions, external factors such as wind speed and leaf dimensions. Okay, at the leading edge of the leaf and by convection at the downwind side of the leaf, mean direction of the leaf to the wind and the thickness of the leaf. Generally, small leaves have temperature close to air temperature. So generally, if there is small leaves, then there will be a less boundary layer. Then the temperature of air and canopy is almost close as compared to the large leaves. And in a cold environment like alpine species, increase the boundary layer thickness to reduce the sensible heat loss, because they require heat for their metabolic processes. So they increase the boundary layer, so there will be a less heat transfer between the atmosphere and canopy. So friends, this is about the energy balance, that there are mainly 5 components: short wave, long waves, evaporative energy loss, convective heat transfer and metabolic heat transfer. So how these 5 components regulate the transfer of heat and balance energy balance into the plant. So this is about the topic. I hope you understand, and thank you very much.